And we're live. Hello. Hey, Laura.
Hi, Ramon. How are you doing?
I'm good. Thank you. Can't complain. How about yourself?
Good, good. Doing much better than last week.
Yeah, glad to hear it. Glad to hear you're feeling better. And thank you so much for coming on to do this as always.
Yes, thanks for having me.
Uh, it's a joy. Folks, if you're joining in, thank you so much for watching. If you're watching in the future, thank you. Greetings from the past. Yeah, welcome to our 5th edition of Coding Our First WebAssembly program. Laura and I have been working on this for a few weeks now. It's been a lot of fun.
Mhm.
And last week, I think it was last time, sorry. We got to the point where we had everything running fully in the canvas. In we had a full game of life running. We understood how accessing the WebAssembly heap, not the heap, sorry, or maybe it was a heap, the memory, the linear
Mhm.
memory of
Right.
WebAssembly works. And today we're going to be continuing with that work to do some test writing, which I'm excited about.
Mhm.
And we're going to, depending on the time, get into some debugging as well.
Yep.
Fantastic. So if you don't mind, Laura, since we're kind of splitting jobs today because I can't really, oh, Laura just left the stream. She'll be right back. Yeah. I'll be doing less typing today because my hand kind of hurts, but and Laura will be doing a little, oh, there we go.
There we go. I accidentally clicked Leave Studio, I think, instead of Share.
All good. All good. I was just telling folks watching that you'll be very kindly driving today since I can't really type today, but yeah, it'll be well chill. So, live.
For
And I
some
shouldn't be
reason,
typing a lot.
I'm
Yes.
having to reopen Chrome, even though I have given it permissions to do this many, many times. I'll be right back.
Take your time. Take your time. Cool. Yeah, so we're going to be doing some testing, then we're going to be doing some debugging, and it'll be a lot of fun. Thank you all for watching as always. So we're hoping, let me go ahead and share my screen for a bit while we wait for Laura to come back. So that's Rust Wasm, and I can show you a little bit of what, oh, Laura's back. Hey, hey.
No. Here we go.
Ooh, excellent. Thank you very much for sharing your screen.
Mhm.
And yeah.
Do we have a link in the chat for the tutorial?
No, that's a great point. I was actually just getting it ready. So I'm going to throw that up right away. So here it comes. So we'll be starting right off with the testing portion. I also sent it to you in the private chat. So all good. I'm going to actually put us here in the corner so we have some more space. I think the size looks good. Folks watching, if it's too small, please, as always, let us know. Yep, that looks great in my opinion. Cool. So let's get right to it. So last week I said we got it all running. Now we're gonna add some tests. And if you haven't written tests before, what we're gonna be doing is writing a series of programs that make sure that our code that we're gonna be using for the game of life runs correctly. So it's gonna be some automated checks that we'll run on our own command, be like, hey, run the tests. And if everything is working, if all the tests are passing, if all of the checks we're doing are positive, then that means that we're writing our code right. And this is something that a lot of software that's commonly done in software development to make sure that the code that we're writing is solid. Does that sound good?
Yep, absolutely.
Fantastic. Yeah. So let's start right through it. So now that we've got, oh, do you know what? Very sorry. I just realized that I didn't put out the correct link in our tweet. I'm going to have to fix that real quick. Do you mind if I just quickly handle that, Laura?
Of course.
Yeah, thank you. I will get right on that. But yeah, so what we're going to be doing, let's see. Now that we have our Rust implementation of the game of life rendering in our browser with JavaScript, let's talk about testing our Rust-generated WebAssembly functions. So we're going to be testing that our tick function gives us the universe that we want. So what we'll do in our tests is provide a universe and provide a universe.
Yep.
Oh, could you actually just make it just a touch bigger? Sorry, I
Sure.
just realized. Thank you.
In fact, the other thing that I'll do is, oops. There we go.
So, very sorry. I'm just gonna make sure I get that correct link out. I don't know why I got that wrong. So, yeah, so we're going to be writing some automatic checks to make sure that the code we write is the correct one. So, there we go. Here, 5, come hang with Laura and me. There we go. Yes. Okay. Sorry about that. Okay.
One of those days.
One of those days. So we'll be providing two public functions to our universe to be able to ensure that we can set up a universe correctly. So the first one is going to be that we see here. We're going to be able to give it the ability to set the width of the universe.
I think we did this.
Did we?
I think we did. I mean, I think we invented this in like day 1 or day 2.
Yeah.
Day 2, maybe.
Right. I think yes, I think I know what you mean. I actually see it here on line 55. So when we create a new universe, we supply to it as we're creating it a width and a height, which is good. But what this function is doing here is adding some more functionality so that we can dynamically set that width and height.
Nice. Okay.
If that makes sense.
All right. So we'll just replace, let's see, how much of this do we need to replace?
I don't actually think we need to replace any of it.
Oh, no?
No, because this is setting the, see what we're doing here in new is we're supplying a width and a height, which you see in line 55. And then in line 68 through 72, we create that new universe with that supplied width and height. Whereas set width and set height are functions to be called on an existing universe.
Right.
As opposed to creating a new one, if that makes sense.
Yeah. Yeah. Getting there.
Cool. Like, feel free to stop me at any time.
Sure. Okay. So, oh, go ahead.
No, please.
Just thinking about, okay, so where do we need to put this? So this needs to go, this new public function set width that we're creating would go inside our new function, right? Or let's see. So this new is a function.
Yes.
And so is this going to be like a subroutine of our new, or is it separate?
No, this is a separate function.
Okay.
So just like render and tick, we're going to be adding two new functions, which are set width and set height.
Sounds good.
And it'll be public. It'll be a function called set_width. And this moot self, that means that we're going to be modifying our universe. And the first parameter it takes is a width, which is an unsigned integer.
All right.
Cool. So the first thing it'll do is set our width.
Oops.
And by doing self.width equals width, what we're doing is saying, hey, take the property of our universe, the width property of our universe, and set it to be the width that we supplied. Now, this one's a little more interesting, what's going on here with the cells. What we're doing here is, right, since we're creating a new width, since we're setting a new width, we actually need to reset our cells as well, if that makes sense.
Right. Like in a reinstantiating our cells kind of way, or keep the cells that we already have and then add some new ones kind of way?
That's a great question, and I don't know because we haven't scrolled right yet.
Okay.
No, see, it's setting them all to be dead. So it's really like resetting the universe.
Mm-hmm.
Setting everything to be dead. It's a bit morbid.
Where is my... Shoot. I don't know where that got mapped to. I'm just going to copy this one for here.
Yeah. Yeah, because what's going on here is that we're looping through we're looping through 0 to width times height. And we don't really care about that index, hence the underscore.
Oops.
So I think one thing missing here is after dead, you want to close the bracket.
Oh, yeah.
Because that's our mapping function there. We're just getting a bunch of cell deads. And I think you want to remove that final closing bracket at the end of the line.
There it is.
Excellent.
Nice.
Awesome. So next we're going to do, that's actually done. Next we're going to do the same for set height. Do you want to go ahead and copy paste it, or do you want to write it out?
Sure. Yeah. It's just
because I think the concept is going to be pretty much the same.
Yeah. Okay.
Wonderful. Yeah, so there we can see, okay. Would you mind scrolling up just a touch, please? Awesome. So let's see. We're going to create another impul universe block inside our librs without the Wasm bind gem attribute. There are a few functions we need for testing that we don't want to expose to JavaScript. So what's going on here? We're going to be writing some public functions on our universe struct that we don't want to expose to JavaScript. So, and the reason we want them to be public but not accessible to JavaScript is because we want them to be accessible from the tests. Does that make sense?
Right. Yep.
Yeah. So let's add an impul universe block, I would say below line 112. And this is kind of nice that it lets us create multiple implementations of that struct. Because then we can, go ahead and define many of these as we need, with and without Wasm bindgen as needed. So we're defining here a function called getCells, which returns, that's the arrow, an array of cells. One thing to watch out for is between get and underscore cells, I think there's an extra space.
There's totally an extra space.
Cool. Fantastic. So what this does is it returns a reference to the cells. And that's about it.
Great.
Fantastic. So that's get cells. That gives us all of our cells. And next comes an interesting new one. We're gonna set cells as well. So this is gonna, let's see. set cells to be alive in a universe by passing the coordinates, I think. No, the row and column of each cell as an array. So this is cool. So we're gonna be essentially, just for the sake of the tests, adding a function that lets us define which cells in our universe are alive.
Right.
By giving it an array of rows and column pairs. Oh, watch out between, I think you need to put that between line 117 and 118 so that it's inside that implementation block. There we go. So this will be set underscore cells. And it's a mutable self because we're going to be resetting those. We're going to be setting new cells.
Yeah. So you said we'd be doing that dynamically. So what does that look like? Like on the, is it user provided, or like where does the dynamism come in?
Sorry, I'm not sure I understand the question.
So when so it's going to be mutable so that we can change it.
Yeah.
When will we be changing it? So that'll be at the time that we call the function, or will we be giving the user the opportunity to define the height and the width and the height?
These are going to be available for a function call to that universe. So it's pretty much up to us when we want to call them.
Okay.
But that universe itself will need to be mutable.
Right. Okay.
Because you remember that you can make a variable, you can declare a variable to be mutable.
Yes.
Yeah. Now, that cells parameter is interesting because what it is, it's a array of pairs of integers. Right? And this is called a tuple. It's like an array of tuples. So we're taking that array, that rows and column that Laura just wrote here. So we're going to loop through each row and column pair in cells.eater.cloned, which we remember to be, that's going to be each key value pair as an iterable and cloned. Whew, okay.
Want to run all that by me again?
Yeah, sure. Sure, because we have an array that's that U32, that's that square bracket U32, and we're gonna make a for loop where we're storing the value of each coordinate pair in row and col in line 120. So for this, each of these in, and this cells.eater.cloned is saying like, take that cells array, make it into an iterable. That is something you can iterate through or loop through. This is like a very rusty thing to do, at least where I've seen it. And cloned is just making a copy of all of them, just so that we can access them as needed. I'm guessing. Otherwise, the compiler might complain at us. And I would say, for curiosity's sake, let's remove that cloned when we build it, just to see what happens.
Okay.
If that's okay with you.
Sure.
Awesome. So then in line 121, what are we doing? We're setting a variable called IDX, short for index, where we get the index of that cell from that key value, that coordinate pair. And then we're setting the cell at that index to be alive.
Right. Okay. Sounds good.
Fantastic. Awesome. So once that's done, we're done. We're going to now create our test. So we've got Wasm Game of Life. Do we have a test folder? Yeah, we do. And WebRS. So these are our tests. And we actually, you can see here in between lines 10, and 13, we already have a test that's been pre-generated for us.
Mm-hmm.
Jessica says that makes sense so far. Very glad to hear it. Hi,
Yay.
Jess. Thanks for stopping by. Where were we? Yeah, right. So we've got this test, which is auto-generated for us when we created this project, that is designed to pass. That's why the test is called pass. So it asserts equality of these two parameters, 1 + 1
Right.
and 2. And we can actually run that right now.
Okay.
So I say we do it. Shall we
All
open
right.
up let's open up a terminal here. I think you can do it in VS Code, or
Oh,
we
okay.
can use your terminal, whichever you prefer.
I like mine.
Let's do it.
All
You mind
right.
making it a touch bigger, please? I think that size is good.
Great.
Perfect. Please, folks in the chat, if it's too small, let us know. Okay. So now we're going to run our test using Wasm pack.
Okay. How do we do
So
that?
we're going to run the command wasm-pack.
I'm just going to copy and paste this because
Absolutely.
that works better. Okay.
Oh, a
Oops.
pinch bigger
Wait.
wouldn't hurt, please. Thank you, Jess. Cool. So let's run that. So this is testing it, and this is interesting. It's running our tests in a browser, I guess. Oh, Seichan is saying also love it a bit bigger, please.
Which one? All of them?
I guess the terminal for now, and then we can also make VS Code bigger as well. Awesome. Thank you all for letting us know. So we're running Wasm pack test Chrome headless. So this is going to run our tests in Chrome headless. Are you familiar with headless Chrome?
I'm sort of mentally mapping it to like the way that localhost is, so it's like deploying just locally, but that might not be a correct mental mapping.
I guess kind of what it does is it sorry, my dog's a little upset. Where was I? Sorry, I blanked.
Oh, headless.
Headless. Oh, yeah. It's running the browser without a window, or with the window in the background.
Oh, okay.
A lot of automated web app tests do this, where instead of opening a browser window, it just has let's say an invisible browser window open in the background where we can run our tests. Now, I fear nothing's happening, which is odd. But according to the instructions, we can also try with Firefox, Safari, or Node. Do we want to try that? Maybe with a different browser? Oh, never mind. Sometimes did you do something?
No, I think it was thinking.
Yeah, very fair.
We were rushing it, I suppose.
I'm sorry.
It's tired. Yeah. Am I missing something on the bottom here? There it is. Okay.
Yeah. Awesome. Which actually might be moving it just a touch over to the right so we can see because otherwise our faces are going to block it a bit.
Gotcha.
So that now it's running. Oh, look at that. So now it's running in Chrome. And the tests have passed. So, and we can try it out in a different browser. Do we want to try it in a different browser, or shall we go back and implement our test?
I think we can implement the test.
Okay, cool. So we will need to, let's see what we got here. So back in the test, we will need to export our Wasm Game of Life crate and the universe type. So we're going to declare use of Wasm Game of Life. And then we're going to use or import. I think use is like the Rust way of saying import. Wasm Game of Life universe.
Okay.
Oh, sorry. I think you. Hold on. In line 6, that's Wasm bind gen test. I think that's different.
Oh, yeah. Okay.
Perfect. And I think we also need to extern create Wasm Game of Life.
Yes. And crate, am I remembering correctly? Is that the package manager?
Yes, that's a crate is a package.
Oh, okay.
Exactly. So we're going to declare the use of a crate of the package Wasm Game of Life. And we're going to use the struct universe from Wasm Game of Life crate.
Nice. Alrighty.
So I think, right, now that we've done this, we'll want to create some spaceship builder functions. We'll want one of our input spaceship that we'll call. So we will create an input spaceship. This will be a spaceship. A spaceship. Yes. A spaceship is a term for a group of Wasm. No, sorry, not a Wasm of cells in a game of life.
Right. And we have, where was that? Was it in rules?
That's under rules, yeah.
And that's what it would look like.
Yes, exactly. So this moving thing. Can we just look at it for a sec? I think it's kind of cute.
Yeah.
Please. Thank you. I love it. Like, so that's a spaceship, right? And this one is moving. It's what it's doing. You can sort of see by the scrolling, right? This is a set of cells that's just by the rules is going to be moving over to the right. So we're going to programmatically create one that is in the shape of one of these arrangements. We're going to make it tick, and then we're going to check that it looks the way we expect it to look.
All right.
Does that make sense?
It's funny, in like a Rorschach way, that is not remotely, that's just not even close to a spaceship for me. That is absolutely a fish. Like, that is unambiguously a fish.
Yeah. And if you think about it, calling it life makes more sense that way because,
it does a bit. Yeah.
And it's got a bit of a marine life thing going on.
Yeah. Anyway.
So, right, we're going to create two functions, one to create an input spaceship and one to create an output spaceship. I would suggest let's write out the input spaceship one manually and the expected spaceship we copy, if that sounds good.
Sounds good to me.
Seichen says, a fish that wants to be a spaceship. Yes, very accurate. I love that.
Who are we to oppress the fish?
So that returns a universe, right? And here we're declaring a mutable variable, right? Because we want this to be a universe that we can change. Oh, no, carry on.
Oh, okay.
So let's stop here for a second. And now I see why you were asking about set height and get height with set width and get width before. Because in our test, we need to set that width and height. Right? You see where it says universe set width and universe set height. But that's because they don't have our functionality.
Yes, it is.
So what we can do is supply the two parameters right here.
Okay.
In our new function. So Do you know what I mean?
Yeah. So do we need to pass those as arguments to our input spaceship?
Yes, so not into the parameters to the input spaceship function, but rather in line 18 to that new call.
That makes more sense. Yeah. Okay. And I don't remember what we called them. Do you?
No, but it doesn't matter because we don't need to actually use them. We're just making a new spaceship.
Okay.
So if we go back to librs, we can take a look at what those parameters are. If you scroll up, please. Oh, no. Oh, yes. Sorry. A little bit higher. There. So the first parameter is width and the second one is height.
Mhm. Okay. So we can just supply width and height here.
Yep. And we want these to be, sorry.
Oh, go ahead.
We can see from the test that we want these to be both 6.
So would we just say width equals or width colon? Which one
No,
of those is the assignment for this?
it's just 6,6.
Oh. Oh, okay, sure.
Yeah.
Gotcha. Mm-hmm.
Cool. Awesome. So we would do set width and set height, and we've already done that. So now we're going to set the cells. And we're going to set that to be an array. And then we're going to pass in a bunch of coordinates. And feel free to copy them if you like.
Yeah, I think I will. So these coordinates are chosen specifically because they are going to provide us with that spaceship shape
Exactly.
rather than just some random shape.
Exactly.
Mhm.
We're saying very, very specifically, that. And then we will return that universe.
Mhm.
And now we're going to do the same for the expected spaceship. And here we're just going to copy paste what this is going to be. This is the outputs. Oh, sorry, expected spaceship. Right, because that's the one we expected to take shape of after we go through the universe.
Mhm. And then I guess we can just make the same adjustments here.
Correct. Now, one thing we shouldn't forget is to add that CFG test macro on top of each function. I don't know if you see it.
Oh, I thought that was a comment.
Yeah, it's kind of weird. I think it is a comment, but it also tells the compiler some stuff.
Gotcha.
I don't know what it says to it. I think it's like, hey, this is a function that's going to be available to the test.
All right. Oh, sorry.
All good, all good. Cool. So now that we've created those functions to create our spaceship, now we're going to write the actual implementation of the test itself.
Mm-hmm.
So what do we got? Implementation
Excuse
for a
me
test.
for one moment. I'm just going to close my window.
All good.
Here we go.
Excellent.
There's a dog in a park, and my mother loves the dog. Is what's happening behind the scenes.
Very fair. Very fair. Cool. So test. Right. So we're gonna write a new Wasm bindgen test.
Mm-hmm.
Shall we replace the past one? Do you think?
Sure.
Line 13. So let's rename that to test_tick. So we will create a mutable variable called input universe. So, and we want it to be mutable because we want it to tick.
Right.
And since this is a function, exactly. Perfect. Then we're going to have an immutable variable called expected universe, which will just be an expected spaceship.
Oops. Oh, no, that was all good. I'm not used to the window being so, I'm not sure whether to call it big or small.
Zoomed in?
Depends on your.
Do you want to, would it help you, Laura, if you toggled the project view? I think if you click on the top left where the two papers are, I think you can toggle away the project view at the top left. Sorry.
Oh. Oop. Hang on. Go away. How do I make that not be there?
Definitely don't want to close all. Maybe close this one on the right. This WebRS on the.
Ooh. Yeah. Okay. There we go.
Perfect. Nice.
All right, and then you were saying here. Gotcha. Okay.
Perfect.
So
now something odd's going on here. Why?
Oh, I've got an extreme.
Oh, good call. I was like, why is there some weird thingy syntax highlighting? Cool. So next we're gonna make the universe tick. So we're gonna make it go forward once. And then we're gonna assert that now the input universe is equals to the expected universe by getting its cells. And then the second argument will be the cells of the expected universe. Awesome. One thing to do is to put the semicolon at, nice. And I think we're ready to test drive this.
All right.
So if we can, now it's a lot more like, ooh, a test failed. How exciting. Let's scroll up. Oh, and I love this. I don't know if you've ever seen this.
Panicked.
Rightfully so. But check it out. You can actually see so it's being like, hey, you wanted me to check that these were the same, but on the left I have this, and on the right I have that. And there you see an array: alive, dead, 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 alive. But notice, like, just the second one is different in both of them.
Right.
And I know why.
Because these are different coordinates, right?
Which ones? No,
in the two tests, we have different stuff set up here.
Yeah, but that's fine because the expected spaceship is what we expect it to be after we tick once.
Oh, okay, gotcha.
So the problem is, you know how sorry, could you go back to the test writing?
Yes.
So the problem is, in our input spaceship and output, expected spaceship functions, we're not actually doing the same as the tests are. Because you see, we're setting some alive cells. But if you remember, set width and set height reset the universe to be all dead.
Oh, okay.
But our new, if we go back to our librs, our new function initially sets every cell to be either alive or dead based on a random number generator. So actually what we're doing is, let's say we have like a pattern set of cells, of random cells. Instead of wiping the universe clean, which is a weird thing to say, but you know what I mean?
Yes.
Instead of wiping the universe clean and then applying a new set of alive cells, we're instead we're taking the universe as is and putting some new alive cells on top of it. And the reason why that's happening is because if you go down to set width and set height, here, if you scroll down a bit to set width and set height, you remember that in line 105 and 110, we're resetting them all to be dead. So the question is, what do we do? I have an idea, but I'd love to also like give you an opportunity to come up with one.
No, go for it.
Well, what I would say we could do is when setting the cells, before we set those cells, kill all cells.
Okay.
Does that make sense? So what we can do in set height is, you see in line 110 where it says self cells equals?
Yes.
Let's copy that line. Perfect. And then in set cells between line 119 and 120, let's just replace that there. So when we're setting the cells, we first kill all the cells and then only set the ones we want to be alive.
That makes sense.
Awesome. One more thing we have to do though is in line 120, you see we're having a number go from zero from zero from 0 to self width times self. That needs to be either self height, I think, instead of just height. Right? Because we're not supplying a new height. Almost done. I would also go as far as to say, let's remove set width and set height since we're not using them.
These functions?
Yeah.
Okay.
Or at least comment them out.
Yeah. Oops.
Perfect. Let's try running our test again and see what happens. I'm excited.
Yeah. Yay!
Nice. Okay, cool. Yeah, we did it. And that I don't know about, like, I'm happy to say that felt mostly pretty painless.
Yeah, I think so.
Yeah. I'm pretty happy with that. Cool. Well, I'm afraid we're going to have to stop a little bit early because Laura is going to be streaming again.
Yes.
I'm very excited. Could you tell us a little bit about, sorry.
Oh yeah. So it's about when I was applying to become a technical writer and considering, the role and so on, I really didn't have a clear idea of what it would really look like to work on docs. And right after I started at Suborbital, you walked me through how to make some changes. I'd never worked in a shared GitHub repo before. And so I thought, wouldn't it be great if everyone else had access to Ramón, basically? And so I'm going to stream my version of Ramón.
I'm super excited. I mean, it's got to be better than what I'm providing. So.
Oh no.
Laura, would you like to give us your Twitch username? Because I'm afraid I can't remember it.
Oh, yeah, it's because it's goofy because
Is it
somebody's squatting on my usual username. So here we are. I'll drop it in the chat here.
That'd be awesome. And if you can't send it to
I
me in the
can't,
private chat.
actually. Can I
No, then
not?
send it to me in the private chat and I can put it out there.
There we go.
Because I think since I'm running the stream,
Mhm.
only I can post it there. So there we go.
Gotcha.
So go check out Laura's next stream. Laura, I commend your energy for doing lots of streaming in a row, but thank you so much. And
Yes,
folks, thank
you.
you so much for joining in. I'm gonna go watch Laura right after this. I'm super excited.
Okay, good. It'll be a mess because it's the first time that I have ever done this on my own. So hopefully it'll be a fun mess.
It'll be great, and I can't wait.
All right. Thanks, everyone.
Yeah, folks, thank
Thanks,
you so much for
Ramón.
joining in. See you later, everyone.
See you soon.
Bye.